Everybody, let's go over some sample problems from the Ultimate Chemical Equations Handbook, and this is questions 6 through 10 on problem set 5-1, talking about how to name coordination compounds. Okay, so when we name coordination compounds, we want to kind of split this in half. Okay, and we want to talk about the positive side and the negative side. There's just like in normal compounds like sodium chloride, NaCl, okay, there is a positively charged side and a negatively charged side, and we have rules for naming the positive cation and rules for naming the negative anion. And then once we've named the two parts, we put them together and we get to name. And so when we have a positive cation, we name this, in this example, we have sodium, that's what we name it. And that rule kind of carries over in these sorts of compounds. And then for this half of the molecule, for the anion, we're going to name it chloride. And notice we have to kind of change the name a little. We drop the chlorine, we drop the ene, and add the IDE. Okay, and so there's some of that happens with these compounds too. So excuse me, and let's get started. So let's look at question number 6, okay? And we're going to split this in half, and we're going to name the positively charged, or the cation side, okay? Now this is an interesting one because notice there are two ligands on this metal. When there's two ligands on the metal, well, we're going to name them and put them in alphabetical order, okay, by the ligand. And so we have to know what the names are. This is aquo, okay? If you look over here, I have the names are aqua, I guess that one is. And this is chloro, okay? And so typically I name these backwards. I would go dichloro, but I can't do that because I have to name the aquo first. So I'm going to go tetra aqua. I think it's aquo, okay? And then I'm going to go dichloro. Okay, so I'm naming the ligand parts first. So tetra aquo dichloro. And now I'm going to do chromium. And just like here, sodium's name didn't change at all, right? Because sodium, it was a metal. We're not going to change chromium's name either. Okay, so that's chromium, but it's a transition metal, so we need to know what its charge is. Okay, well, this guy is chloride. Chloride is, and I'll do this in green to separate it. Okay, chloride is a 1-. Okay, now so that means that this side has to add up to 1- total to make sure that the charge equals 0. So this is a chloro, and that's a 1-, and you can tell from your table. Okay, the table in the book, or however you got the table, is a little more clear than this one. I'm just using this one as a little bit of a reference. Okay, so there's 2 of those, so that makes the overall charge here 2-. 2-. This is 0, so that's not contributing. So how are we going to get 2- to equal plus 1- to equal 0? That means that chromium has to be 3+. Okay, so chromium here is going to be chromium 3, and then we go chloride. Okay, now this shouldn't be capitalized. Okay, there it is. Excuse me. Okay, so let's look at question number 7. Okay, so split it in half. Look at this guy. Okay, now there's only one ligand here, so we can just kind of name it backwards. Let's name the whole thing backwards. So we're going to do di, and then NH3 over here is this guy, so that's amine, A-M-M-I-N-E, diamine. Platinum, PT is platinum, and then platinum is a transition metal. Okay, so we have to go through our charges. This is chlorine is a 1-, chloride is a 1-, so that makes the total on this side 2-. The overall has to equal 0 because it's a neutral compound. Okay, so that's 2-. This is 0, so what in 2- equals 0, so this is going to be 2+. Okay, so this is 2, and then chlorine, okay, chloride. Now keep in mind, we don't, even though there's a 2 there, we don't put those prefixes, okay? We don't put dichloride, okay? Just like if we were to do MgCl2, this is just magnesium chloride, because the charges make that, make it work out that it has to be 2 chlorines, okay? So just keep that in mind. Okay, I'm going to erase this stuff now. Now we'll move on to number 8. So we're going to, again, split this in half. Now the positively charged thing is a potassium. Okay, well, that's pretty cool. Okay, so potassium, poo, I just spelled poo. Okay, let me get rid of that. Let me try to spell. Okay, so potassium, there we go. That's potassium. That's the positive side. Now the negative side. We're going to name it backwards. Tetracyano. Okay, because cyano here. Cyano. And then copper. But remember how because it's the negative anion, we have to kind of modify some of the sides. Like chloride got modified from chlorine. Okay, and some of the previous examples that we've done, that gets modified. So we're going to do the same thing with copper. That's going to get modified. And the way that we modify metals is we use the 8 ending. And if it's one of these that has a Latin symbol and root, we're going to use its Latin symbol. So this becomes cuprate. Now, the last thing that we have to do, as always, is make sure that we have the charges figured out. So potassium is a 1+. So there's 2 of them, so the overall charge on the positive side is 2+. The total has to be 0, okay, because it's a compound, has to total 0. So if it's going to total 0, let's see. Let me make sure that this is legible. So this is 2+. Okay, the total has to be 0. Okay, cyano is 1-, so that means the total for the cyano is 4-. So how does 2+ and 4- equal 0? That means that copper has to be a 2+ as well. Okay, so this is potassium tetracyanocuprate 2. Okay, that's what makes these compounds so interesting, is because that's not what makes the compounds interesting. It's just interesting names that we have here. Okay, so let's go through again. So for number 9, again, we'll split it in half, name the positive side. So this is going to be hexaquo. Okay. Oh, man. And then Cr is chromium. And we keep that name the same because it's part of the positively charged cation. Okay? And then chromium, and now we have to figure out its charge. And actually, I'm going to show you a little bit of an alternative, or a different kind of different timing for this. I'm going to just leave that blank. And now I'm going to name this half. Okay? So then that half is nitrate. That's a typical ionic anion, right? When you're naming just kind of binary ionic compounds or compounds with polyatomic ions, nitrate is kind of the most common polyatomic ion. And so notice again, we don't name the 3 there because in ionic compounds, that number is assumed based on charges. Okay, we can figure all that out, so we don't try to repeat ourselves as much as we can. Okay, so now charge, let's go here. So to figure out the charge on the chromium, nitrate is 1-, there's 3 of them, so that's a 3-, and it's because it's an element, because they're all neutral compounds, because this is all a neutral compound, it has to equal 0. So this size is 3-, and water, aquo, is 0, and so that means that what plus 3- is going to give us 0, so that makes this 3+. And so now what I'm going to do is, instead of doing this at the beginning, I'm going to do that at the very end. I'm going to just put that in parentheses at the very end. Okay, so number 10. Split it in half. Name it backwards. Now this is interesting, okay, because this guy is one of those complex ligands, okay. It's one of those ligands that is that gets a special beginning, okay. Now there's 3 of them. The special beginning, if there's 3 of them, is instead of tri, we call it tris. Okay, if it's 2, if there's 2 of them and it's ethylene diamine, okay, we would call it bis. Instead of bi or di, it would be bis. Okay, if it was 4, instead of tetra, like there, we would call it tetrakis. Okay, it's just the kind of what happens. We don't usually see tetrakis often. Okay, to have 4 things that are big and bulky around a metal is not as common as seeing 2 or 3. So this is tris, and then it's tris ethylene diamine. Okay, and that's just following that. Okay, and then cobalt, because we tris ethylene diamine, and then we cobalt. And now I'm going to do the same thing that I did on 9. I'm going to leave that blank. Okay. By leaving it blank, I'll come back to it, and then I'm going to name that last thing bromide. Okay. So now we're going to come back to it now. Bromide is a 1- charge. Always in ionic compounds, it's 1-. So that, and let me get rid of some of this junk to try to clean this up a little. Okay. So this is 1-, so that means there's 3-, because there's 3 1-. So that's going to add up to 0, or because it's a compound, it has to add up to 0. Now ethylene diamine has a 0 charge. Okay, so there's 3, and so that doesn't contribute to the charge. So cobalt, 3. What plus 3- equals 0. So cobalt, there's 1 of them, so cobalt's going to be 3+. And you'll see kind of a pattern. A lot of these examples that we do have charges 2s and 3s. 2 and 3 is kind of the most common charge for transition metals. So there it is. That's the second half of problem set 5-1 in the Ultimate Chemical Equations Handbook. Feel free to use this however it's going to help you. Have a great day.